Look at some application problems involving growth and decay. The first question here is talking about bacteria. It says that bacteria can multiply at an alarming rate when each bacteria splits into 2 new cells, thus doubling. So our rate, that change is happening, is a rate of 2, that doubling. That is the base. You remember how we looked at our exponential functions? I didn't tell you, but they're in the format y equals ab to the power of x. This is kind of that standard format. If your b value is a number greater than 1, it's growth. B number less than 1, like 1/2, 1/3, something like that, that's decay. The a value is your starting amount that you have, and x is like the time, or the number of times that it doubled in this case. So it's doubling, so our base value is 2. If your dust starts with only 3 bacteria, that's your starting amount that you have, and it's doubling every hour. So our power is going to be the number of hours. So if it says 6 hours, that's going to be our amount of hours. That's our power there. And then we're just going to solve for what this value will be. So 3 parentheses 2 to the power of 6. 192. So we would have 192 bacteria after 6 hours. So this is your general growth decay kind of format, but if they're giving you a rate as a percentage, then you're going to be looking at it as your initial amount, and if it's increasing, you're going to put plus the rate as a decimal, and then the power is, usually we put t there, like the number of time, and that's really just how many times things are happening. Like if it's every hour and you have 4 hours, that number is going to be 4. If you are having a decreasing percent, you're going to have your initial amount and then 1 minus that percent to that same power of t there. So these are kind of the 3 basic formats that we're going to be looking at. An adult takes 800 milligrams of ibuprofen. Each hour, the amount of ibuprofen in the person's system decreases, so we're going to be doing that minus formula there. So they started with 800. It's decreasing, so 1 minus. We need to express this rate as a decimal, 0.29, because a percentage is out of 100, so if you divide this by 100, you'll have that decimal value. How much ibuprofen is left after 4 hours? The time is 4 hours. So I'm going to go over here and I'm going to change this up. I'm going to start with 800. I'm going to make this 1 minus 0.29, and I'm going to make my power 4. So 203.29 milligrams will be left after 4 hours in their system. Next one says you drink a beverage with 220 milligrams of caffeine. Each hour, the caffeine in your system decreases by about 12%. So we're going to start with 220. We're going to decrease, so 1 minus. We need our percent as a decimal, 0.12. How long until you have 10 milligrams? Okay, so we don't know the time. So I'm going to call that x, and I'm going to set this up as like a y equals. And what we're looking for is when is the y value equal to 10? It's kind of like a system of equations. And I'm going to solve it that way using Desmos. So over here in Desmos, I'm going to move it over so we can see the graph. We're going to set up our, make it y equals, I'm going to make this 220. And then 1 minus 0.12. And then our power needs to be x. And notice that you can't really see it. So that is something that you're going to need to like zoom out. So here we go. I've zoomed out some so I can see the graph now. We want to know when the y value is 10. So we're going to say y equals 10. And that gives you a line so that you can see when these two lines are crossing, that is when the y value is 10. So if you go there and you touch where it's crossing, the x value is the solution. So x equals 24.18. So I'm going to say about 24 hours. That's probably the hardest kind that you're going to have to do, where you set up that system and you find where they're crossing. Sometimes you have to zoom very carefully on Desmos and it can get very irritating. So just, be patient and keep working with Desmos to find where they're crossing. If you have a graphing calculator, you could also type in this equation into your graphing calculator, go to the table, and then scroll until you see the y value to be about 10, and then add that x value is the answer. So if you have a graphing calculator, you could do it that way. Number 4 is asking a multi-part question here. It's got a population of, well, I cannot say that place in Nevada can be modeled by this equation here, where t is the number of years since 1990. What was the population in 1990? What percent the population increased by each year? And what's the population in 2017? So see how it says 1.08 in there? That's because they have simplified this 1 plus 1 minus thing. 1.08 is more than 1. It is 0.08 more. So they have added a percentage of 8%. So I can tell the rate increased by looking at that number. The population in 1990, that's the initial value there. So it's that 6,287 that they started with. And to get the population in 2017, I'm going to do this equation, 6,287, 1.08. 2017, so like 1990 to 2017, that's 27 years. So that power will be 27. So I'm going to go over here into Desmos, and I'm going to type that in. So 6287, 1.08 to the power of 27. And I am getting 50,220.94. So I'm going to say about 50,221 would be the population in 2017. So that's all you're going to be doing. Again, when they want you to find how long until a certain number, just remember to create the two equations, find where they're crossing in Desmos. That's the hardest thing. Don't forget to convert your percent to a decimal.